with a couple of these. I was looking at them and they're all pretty much the same thing. It's doing the molarity, the molality, mole fraction, mole percent. I think the biggest thing with these type of problems is knowing the definitions or the formula for them. So if I pull up 12.6, it looks like the first one you had. This is what I have right here. Hydrochloric acid is purchased in a concentration that is 37% hydrochloric by mass. Okay, so remember this is a percent by mass. Okay, and it has a density of 1.2 grams per milliliter. How much concentrated solution would you take to prepare 3 liters of 0.44 molar HCl by mixing the water? Okay, so the hardest thing here I think is getting started. Okay, so where do you start? And what I always say is start with the most simple units. Let's see what everything we have. So we have 37% hydrochloric acid by mass. So let's see what that is. So we have, oops, 37 grams of hydrochloric acid. It was 37% by mass. So if it says 37%, remember percent is always 100. So what that means is 37 grams of hydrochloric acid per 100 grams of solution is what we say. Okay, so it's always per 100, and it's always whatever the molecule is over the solution. Okay, so this is one unit that we have, the percent. We also know that you have let me pull this back up. Let's see, 1.2 grams per milliliter for the density. Okay, so you write that down. The density equals 1.2. This is going to be grams of solution because this is the density of the solution over milliliters of solution, because that is the definition of density, is gram per milliliter. Okay, and then we have 3 liters and 0.44 molar. We have 3 liters of solution and 0.44, and molarity is moles of solvent, so moles of HCl, if you want, over liters of solution. So knowing everything, it's going to be very important to know when something is solution and which one is your solvent. Your solvent in this case is water usually, and then your solution, or your solute equals to HCl. Okay, that's usually the one they're talking about in the problem. Okay, this is your molarity. Okay, so we start with the most simple units. Do you see this one up here has 2 units? This one has 2 units in it. This one has 1, and this one has 2. Meaning, you know, this is a gram per milliliter, gram per gram, mole per liter. So this one is just a liter. So let's start right here. So we have, put it over here, 3 liters of the solution. And let's make sure we know what we're solving for. We're trying to find out how much of the solution do you need? Yeah, how much of the solution do you need to add in here to make 3 liters of 0.44 molar solution, okay? So we have a beaker. Let me kind of explain what this means. We have this beaker over here, and we have this solution. Okay, so we have some hydrochloric acid right here, and we are trying to make this new solution. We want 3 liters, so let's say this is 3 liters, and we want this to be a 0.44 molar solution. And we know that this little vial here has 37% hydrochloric acid. So what it wants to know is, in this beaker right here, how much hydrochloric acid do I need to put in there? How much of, let's see. Yeah, basically how much hydrochloric acid do I need to put into this beaker? Okay, and let's get started. So we're starting with 3 liters of solution. Okay, because that's what we're trying to make. That's in our beaker. Okay, so how do I get rid of the liters? Because I don't want liters of solution as my final unit. Okay, so let's look at all of these that I have up here. And let me change the color. There you go. Okay. So I have, let's see what has a liter in there. Oh, look, right here in the molarity, I have a liter of solution, and that's what I'm trying to get rid of right here. So let's use that. I know that there are 0.44 moles of HCl per 1 liter of solution. Okay, good. So that gets rid of liters of solution, okay? Now we need to get rid of moles of HCl. Okay, so let's see. Grams of HCl, that doesn't help me. Gram, milliliter, liter. I've already used this one. I just used that one. Okay, none of those help. So if I want to use, I'm trying to go from moles, and then it looks like I can eventually use grams right here. So I guess one of the other tricky parts of this is knowing that you need to use the molecular weight of hydrochloric acid. And if we look on the periodic table, chlorine weighs about 36.5, and then we add 1, or 35.5, and then 1 for hydrogen. So the molecular weight is going to be 36.5 grams per mole of HCl. Okay, so now we can use this unit right here. Anytime you're stuck on something, more than likely this is what you're missing, your molecular weight. Okay, so I want to get rid of moles of hydrochloric acid. So I know that for every 1 mole of hydrochloric acid, I have 36.5 grams of hydrochloric acid. Okay, so now I have moles of hydrochloric acid gone. Now I need to get rid of grams of hydrochloric acid. And I can use this right here because you see I have grams of hydrochloric acid. I know there are 37 grams of hydrochloric acid per 100 gram of solution. Okay, so now we're back to solution, so that's good. So now we just need to use our last one to get the milliliter of solution. So we use 1.2 grams of solution per 1 milliliter solution. So now our grams of solution crosses out, grams of solution. That's why I knew to put it down here. Grams of hydrochloric acid crosses out, and our final unit is in milliliters of solution. So how much of this vial do I need to put in there? So we multiply it all out, and actually it gave me the answer. 108 milliliters. So we need to put in there equals to 108 milliliters. We need to put in 108 milliliters from this vial into this beaker to create 3 liters of the solution. So what that means is, so if we convert this to liters instead, so divide by 1,000, 0.108. So we're going to put in 0.108 liters of this vial, and then the rest of it, which is going to be, what, 2.9 liters, will be of actually water. Anyway, you don't have to do that very last part there, but I'm just telling you. So if you put in 0.08 there, that means the rest of the 3 liters will be water. Now, I'll tell you right now, this was a really, really long one. The ones on your exam aren't going to be this long. This is a lot of unit conversions here. But the thing to keep track of is the actual definition of, molarity versus density versus when is something the solute versus the solvent, which is, those sort of things. Okay, so let me do one more, and I'm gonna leave one for you to do on your own to see if you can figure it out after we work these. So let me do, oh great, looks like I got out of it. So let me pause this and pull up the next one. Okay, so this next one, this is 12.67. Now let me do this one, and I'm gonna leave the last one to you. Okay, we have, oops, right here, 12.67. And it just tells you have 38%, I think it was hydrochloric acid. Let me make sure. Hydrochloric acid, yeah. Hydrochloric acid by mass, and it wants to know the molality. Okay, so first let's define molality. Molality equals to moles of solute over kilograms of solvent. Okay, not of solution. A solution equals to solute plus the solvent. Okay, it doesn't want that. It's very important to know. Okay, so, and now let's see, we have 38% by mass. So what that tells us is for every 100 grams of solution, there are 38 grams of hydrochloric acid. Okay, that's what this tells us. Thank you. Okay, let me change the color again. Okay, now let's work out what we know. Now the only number we have is right here, this 38 grams. So let's start with that. Now we know there, we always assume it's over 100, okay? So if we have 38 grams of hydrochloric acid, okay, that's my solute. My solute is hydrochloric acid. Now, in molality, we want to convert this to moles. So if we have 38 grams of hydrochloric acid, how do I put that into moles? Well, anytime you go from grams to moles, you always use molecular weight, okay? So there are approximately 35.5 grams per 1 mole of hydrochloric acid, okay? So when we do this, we get about 1.07 moles of hydrochloric acid, okay? That's great. That's the first part right here solved. Check. Okay, but now we need to figure out kilograms of solvent. We know how much solution is in there, and we know how much solvent is in there, or solute, sorry, but how much solvent? Okay, well, let's look at this formula that I wrote right here. Okay, I'm assuming I have 100 grams of solution, okay? I have 38 grams of solute, and I don't know how much solvent, so I'm just going to put X. So when we do this, this is just going to be 100 minus 38, which equals to 62. So I know I have 62 grams of solvent. Okay, but what unit do I want this in? I want it in kilograms. So I'm going to say, okay, I have 62 grams of solvent for there are 1,000 grams per 1 kilogram, so I can convert that to kilograms. So this gets me to 0.062 kilograms of solvent. Okay, so check, I have everything. Let me change this color again to red, I guess. Okay, so my moles of solute is 1.07, which is of the HCl, which is what I solved for right here. And then I have 0.062 kilograms of solvent. So when I do this, I have the answer here. Let me pull it up. You should get 17. Approximately 17. Okay? Now let me just set up this next one for you, and then I want you to try it on your own. And you use the same information here, so let's remember this. So kind of remember it. I have it written down. Let's look at everything we've solved for. So we know there are, oops, back here. 62 grams of solvent. What was it? 38 grams of solute. And if we want, we already solved for 1.07 moles. And 38 grams per 100 grams so of solute, which I believe was HCl, over solution. Okay, and it wants us to find the mole fraction. Now let's define mole fraction. So it's mole fraction. Mole fraction is the moles of solute over, sorry, let me get rid of this. Go away. Let's see, moles of solute over, what are we doing? Moles of solution. And remember that solution equals to solute plus solvent. Okay, so look at what we have here. We know how many grams of solvent we have. We know how many grams of solute. We already know the moles of solute. Sorry, it's my little boy. So I know that I have 1.07 moles of solute, which works right here, but I need moles of solution. Okay, so what I need to do you see I have my solvent right here, and I have my solute right here, and look, just so if I want my moles of solution, I have to add those together. So what I can do, I already have my moles of solute, so you just need to do your 62 grams of solvent. Your solvent is water. When it doesn't tell you, then it means it's water. Okay, and you just need to convert that to moles. Okay, so then you'll have moles of solvent. So I have moles of solvent. I have moles of solute right here, so to get moles of solution, plug it in there. Okay? So that kind of really sets you up. Pretty much you're done with the problem at this point. Okay? And let me know, do this one and then do the next one and let me know if you're still having trouble with them. Good luck.